When I twist this loop, I'll have a change of flux through the loop. So at the starting position, the flux is 0. None of the field lines are actually going through the hole just because of the alignment of it. But when I twist it, then all of those field lines end up going through the hole. So there suddenly is a flux. So part A, it goes from 0 flux to having flux to the right. That's the direction of the magnetic field. So this change in flux induces a current and which way will that current go? So it can either go that way or it can go the other way. We have to figure out which way it goes. And that's going to be based on Lenz's law. So Lenz's law states the induced current must resist this change. So in simpler terms, I have to take my right-hand rule and I have to stick my thumb to the left. And so that would be right-hand rule number 2. My thumb needs to point left to resist the B that's being introduced to the right. Left resists right. So if my thumb points left, so I have to imagine this has been twisted, twisted by a quarter turn, and I have my thumb pointing left, then my fingers are going to wrap around so that the current will go into the page. If I look at this point right here, after this has been twisted, it's really hard to describe because it's 3D, but after this has been twisted, the current will be into the page. And it would loop around, and down here, it would come out of the page. Okay, so part B, what if you keep twisting it? So part A, we just twisted it a quarter of a turn. And when we do that, then the opening becomes perpendicular to these field lines. However, if we keep twisting it, then we start losing some field lines. We start losing some flux because less of the field lines will end up going through the hole. So things are going to do the opposite. So when we continue twisting, we now start to lose flux, to lose rightwards flux. So we're going to induce a new current into this loop that's going to resist this new change. So this time, my thumb needs to point right. because I'm losing flux, to resist that means I want to try to put some back, going towards the right. And the current will be in the opposite direction as it was in part A. So what ends up happening is that if you keep on twisting it, continuously twist, 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 it will alternate currents. The current will go one direction during one quarter twist, but it'll reverse directions during the next quarter twist, and it'll keep reversing directions as you keep twisting it, and this creates what we call alternating current.